Hi, I'm Jamie Willis-Rose, and welcome to part 2 of my animated clock demo. First, I just want to apologize for the audio. My neighbors are home upstairs, so you may hear some footsteps. I can't do anything about that right now. This is part 2. If you haven't already, you might want to watch part 1 before you watch the rest of this video. So how does it all work? Well, the debug mode gave you a sneak peek, but let's take a deeper dive. So let's start with what happens when the app loads. You can use either onStart or onVisible. They do different things and they have different use cases. In my case, it doesn't really matter because I have a single screen app. If you have a multi-screen app, there definitely is a difference. Do your research if you've never used these properties before. I'm going to be using onVisible. I'm using the now function to initialize this variable current time. Current time is used throughout the app, but I have to first set it before I can use it. Then you'll see the next function here is concurrent. Concurrent is a very useful function when you're loading a screen or loading the app. It can actually improve the performance. If you've never used it, definitely check out the documentation on that. So I'm setting basically a series of variables here that just sort of set their initial state here. And so that's all this really does, is just sort of initializes these variables. And I'll be changing them a lot while you're using the app. And so let's move on. Next, let's take a look at the timer control, which in my app is called Clock Timer. This control has a lot of amazing utilities. You can definitely Google PowerApps timer control and find out a lot of cool ways it's being used by a lot of people. It's not just for time, as you'll see with my app. For our purposes, we're going to be setting the timer to auto start and repeat, and we're going to set the duration to 1, and that's 1 millisecond. I wouldn't advise using 1 millisecond in a production environment, especially if you're making a lot of calls and calculations, but I needed to do it here so I could demonstrate the smooth animation, which I mentioned in part 1. More on that in a bit. Now let's take a look at the onTimerStart property. Here you can see where the magic all happens. Every time the timer repeats, these functions are called. At the top, you'll note the current time is updated to include the hour offset slider, and I'm using the date add function, which has 3 parameters, the date and time, the number of units to add, and then optionally the type of unit. By default, the function uses days, but in this case, we want to add hours to the current time. You'll also note that I'm getting all of this from docs.microsoft.com, which the URL is on the screen there. If you haven't already visited docs.microsoft.com, I highly recommend you go there and bookmark their PowerApps functions reference. I refer to it every time I'm working on a Power App. Next, as I scroll down, you'll see again the concurrent function, which wraps around a series of calls to functions that I'm using here to set variables. So again, current hour, current seconds, current minutes, all use the built-in functions hour, second, and minute that come with PowerApps. There isn't one for milliseconds. There's no equivalent for milliseconds, so I had to kind of hack it. So to do current milliseconds, what I'm doing here is I am using a series of functions. So let's start from the inside out. First is the text function, which in this case extracts the f, or fractions of time, from current time. Note that PowerApps combine the language tag and custom format into one parameter after I saved the app. This is only half the job, however, because this is only going to return the current milliseconds between each second. So we need to take it one step further. And again, I'm getting all this reference information from docs.microsoft.com. To get the actual current milliseconds, we need to add the number of milliseconds already passed. So we use the same second function to extract the current seconds from the current time. And then we add 45. I'll explain why in a bit, just file that away for now. Now we use the mod function. this returns only the remainder after the number is divided by the divisor. Then we multiply that number by 1,000 to get the milliseconds. So for example, if there were 15 seconds, then this formula will return 0 milliseconds. If there were 0 seconds, then this formula would return 45,000 milliseconds. And if there were 30 seconds, then there would be 15,000 milliseconds. And again, I will explain the plus 45 soon. Now that we have the current hour, minutes, seconds, and milliseconds, we can continue to the next group of functions. So here we set the degrees again using the familiar mod function. Note that the current degree hour has a +9, and then the current degree minute and current degree seconds both have plus 45. Any guesses why? So the reason for this mysterious math is because 0 degrees and 12 o'clock don't line up by default in PowerApps. In PowerApps, 0 degrees is 3 o'clock, and 6 o'clock is 90 degrees, and 9 o'clock is 180 degrees, and midnight or noon is 270 degrees. If we don't take into account for the offset, for example, let's say it's 2 p.m., 1400. The hour hand would then end up at 60 degrees, or 5 o'clock. Mod 1424 returns 14. 14 times 30 is 420. Mod 420 360 equals 60. 60 degrees, which is 5 o'clock, which is not the actual current time. It's 2 p.m. So what we need to do is we need to create an offset that takes into account this. So we compensate by adding 9 to the current hour to get the hour hand to appear at 330 degrees. Mod 2324 equals 23. 23 times 30 equals 690. Mod 690 by 360 equals 330, which is 2 on the clock. So you're probably wondering, where does the 9 come from? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 hours between where it appears on the clock face and where you want it to appear. That's where the 9 comes from. Another way to look at it is 9 times 30 equals 270, which is the 12 o'clock mark. Let's take a look at the other degree variables. So current degree minute is plus 45, and current degree seconds is plus 45, which is the same offset we used, if we go scroll up here, as we did in the millisecond, the current milliseconds hack. You'll see here also plus 45. And the reason for that is that 1 minute and 1 second equals 6 degrees. And 6 times 9 is what? 45. So we already added the offset to the current milliseconds. So current degree milliseconds only needs to find the remainder after multiplying by 6 divided by 1,000, or 0.006. Now let's take those current degree variables and convert them to XY coordinates for the hour, minute, and seconds hand, or circles if you want to be technical. Let's start with the hour hand. I'm going to click on the X value to show us the formula. And now comes the trigonometry. Just kidding. If you want to know why my formulas work, there are plenty of resources and smarter people on the internet that can explain cosine and sine. Honestly, all these formulas were figured out through trial and error. I'm not a math genius, but I will go over what each of the functions I used. The cosine and sine functions are part of PowerApps trigonometry functions. Again, refer to docs.microsoft.com. That's where this information is from. Another important PowerApp function is the Trig helper function radians, which converts degrees to radians, which is what we use in the cosine and sine functions. We need to use this function to take the degrees that we have and convert it into radians before we can use it in the cosine and sine function. The other part of the formula keeps the xy coordinates relative to the clock face circle and the shape itself, i.e. the clock hand. I'll note that you may need to tweak this part of the formula if you're using it in your own app. More on that in another video. We can look at the other formulas here. So go to clock hand minutes. Look at X. You'll see it's almost identical to the clock hand hours. Only difference is it's clock hand minutes here. If I go to Y, the only difference is that it's sine instead of cosine. Seconds. Again, clock hand seconds. And of course, current degree seconds. Current degree minute. Current degree hour. And if I go to the second hand smooth and click on X, you'll see current degree milliseconds and clock seconds hand smooth. And you'll note that this is in the center here because it's not being used right now. I haven't actually played this app yet. It hasn't initialized yet. But if I hit play, there it is. And if I hit smooth animation, there it goes. And remember, we have the debug mode, so we can also use this to help us look at both the formulas and the values in real time. Just remember that these formulas are copies of the formulas, not the actual formulas. If you make a change, these won't reflect those changes. One last thing before I go. If I go back to the timer control, there's an on timer start, which I use already and I showed you, but there's also an on timer end. So every time the timer ends, this is what I do. If current seconds equals 0 and the debug mode value, which is a Boolean, then I select settings refresh button. So what does this mean? Well, it means that once a minute, if the user has put the app into debug mode, refresh the clock settings gallery. So you see here, this is the settings refresh button, and this has all the functions needed to refresh that. As you can see here, it's just a collection that I actually written out here. It's hard coded, if you will. Every time this timer gets to 0, if this is visible, it refreshes. Just like that. And of course, you can manually refresh it by just clicking the refresh button. Before I go, I want to give a huge shout out to the folks who helped me as I started my PowerApps journey. I'm truly standing on the shoulder of giants, so please check out these amazing folks and follow them on YouTube and or Twitter if you don't already. Shane Young, aka PowerApps 911, Laura Rogers, and her company IW Mentor. Be sure to check out her SharePoint Power Hour, which is almost every Wednesday, and you can view archived copies of it on her YouTube channel. The Microsoft PowerApps YouTube channel, Mr. Dang, Todd Baginski, and last but not least, Audrie Gordon, the artsy PowerApper herself. I'm sure I left some folks out, but you can find a lot of them on the PowerApps community forum and the PowerApps user group site. Be sure to sign up and check for a local user group in your area. I've already attended events in the DC area and met some really awesome people. Thank you for your time. Please like and subscribe if you enjoyed the video, If you have any questions, you can find me on Twitter at Willis-Rose or on LinkedIn or on the community forum. I appreciate all the feedback I can get. Thank you.